today we're looking specifically at translations. We know a translation is a transformation that is a slide. Translation just slides the object around, okay? Now, this is an isometry. Remember what an isometry is? This is a transformation that preserves congruence. Another word for that would be a rigid transformation. Okay, all that's pretty important for us. We know a rigid transformation, preserve congruence, is preserving shape and size. We're just changing the position of this object. So it says a square has vertices A at 1, 1. There's A. We've got B at 4, 1. There's B. We've got C at 4, 4. There's C and D at 1, 4. That would make sense to complete our square. I'll find the coordinates of the vertices of the image of this square. After a translation of 5 units to the right, show the pre-image and image on the same coordinate grid. Well, this is the pre-image because we haven't done a transformation to it. We haven't done the translation, but we want to shift 5 units to the right. So every point is going 1, 2, 3, 4, 5 units to the right. There's A prime, B prime. 1, 2, 3, 4, 5 is right here. 1, 2, 3, 4, 5. There's C prime right there, and D prime will be right there. It says show the area of A prime, B prime, C prime, D prime is equal to the area of A, B, C, D. Well, 3 by 3 means this has 9 square units as the area here. 3 by 3, this has 9 square units as the area. The shape and size did not change, but the position did. Okay. So we can translate 2 objects. We can use mapping notation. Well, here it says any xy from our pre-image has to be shifted the x coordinates by 1, the y coordinates subtracting 2. So that means we're going 2 units to the right, 1 unit to the right, 2 units down, because we are adding 1 to the x, subtracting 2 to the y. That is mapping notation. Here it says the vertices of this triangle, x at -2, 0, y at -2 and -4, and z at 1, -4. There's our triangle. Find the image of x, y, z after the translation. X, y becomes x plus 5, y plus 4, meaning we're going right 5, because that's adding 5 to the x. Y plus 4 means we're going up 4. So we're going to the right 5. 1, 2, 3, 4, 5. We're going up 1, 2, 3, 4. There is y prime. Z going to the right 5. 1, 2, 3, 4, 5. Up 1, 2, 3, 4. There's z prime. Notice the distance between y and z has been preserved. X going over 1, 2, 3, 4, 5. Up 1, 2, 4. There is x prime. What do you know? It looks exactly the same. It's been shifted over to the right and up. 5 units to the right, 4 units up. Using our mapping notation. We can also translate using a vector. Now, a vector shows distance and direction. Okay, it shows distance and direction. So this is very similar to the mapping notation. Very similar. That's 2, 3. The first value is letting us know how much we should add to the x coordinates. The second value is letting us know how much we should add to the y coordinates. They're both positive, so we're adding positive values to each of these. So for all of our x coordinates are going to increase by 2. All of our y coordinates are going to increase by 3. So here at A, I'm going to add 2 to the x, 2 to the y, and the new point is 2, 3. There is A prime right there. D, I'm going to go 2, I'm going to add 2 to the x, 3 to the y. There's D prime. C is going to go 2 to the x, 3 to the y. There's C prime, and b, 2 to the x, 1, 2, 3 to the y, and there is b prime. Okay, notice there, if we connect those points, a to a prime, b to b prime, and so on, this is the vector in which we've translated. The vector, essentially, that segment that we have moved, we've slid our object about. Over 2, up 3. There it is. Finally, here it says, a character in a new animated movie will move from the point 4, -5, first to the point 16, 3, then to the point 13, -2. Find the vectors of the animators need to apply to the character to make these two translations. Well, first, from this point to this point, the x value increases by 12, the y value increases by 8. So that would have to be our first vector. And then our second vector, we need to go from 16, 3 to 13, -2. Well, from 16 to 13, the x decreased by 3, so that's going to be a -3. And then from 3 to -2, the y is decreased by 5, so we have a -5 right there. So from 16 to 3, -3. From 3 to -2, we had to subtract 5. That would be our translation vector from the second point to the third point. Great.